Hello everyone, welcome to my channel. In this video, I'm going to discuss the example for definite integral. Find the area of the region bounded by the curve where we have y is equals to sine square root of x equals to 0, and the x-axis. So the first part is to find the area. Next, if the region is rotated 360 degrees about the x-axis, find the volume of the solid generated. So kindly focus on the first part where we have area. So the situation will be area equals to integrate where we have sine with the angle square root of x with respect to x for the limit 0 until pi squared. So now my focus is to integrate the situation. So let where we have t is equals to x to the power of 1 over 2. Or we can modify the situation where we have t is equals to square root of x. Differentiate the situation with respect to x. So where we will have dt is equals to 1 over 2 x to the power of negative 1 over 2. So rewrite the situation. So where we will have dt equals to 1 over 2 multiplied with the square root of x dx. Rearrange the situation. So we will have 2 multiplied with the square root of x dt is equals to dx. So do remember, previously we already let the square root of x as a t. So meaning that in here we have 2t. So rewrite the situation. So 2t dt is equals to dx. Next is to substitute the situation. So area is equals to integrate where we have sine t. In here the dx actually is equals to 2t dt. So we have to substitute 2t dt. Next is to integrate the situation. So a is equals to 2 integrate with the t sine t dt. So in here my suggestion would be Bipart method. So let u is equals to t and the dv is equals to sine t dt. Next is to differentiate the u with respect to t. So du dt. Next part, integrate the dv. So where we have v is equals to integrate sine t. So we will have negative cos t. Next is to substitute the situation into the formula for Bipart formula. So uv where we have negative t cos t plus integrate cos t dt. Focus on integrate cos t. So finally we will have negative t cos t plus sine t. So focus on the limit. So in here the limit that we need to have is the value of t. So previously the question given the t the value 0 is for x. Same goes to the pi squared. So now what we have to do is to switch the value of x into t. So kindly focus on this part. If we substitute the 0, and we will have t is equals to 0. Next, if we substitute pi squared into this part, so we will have t is equals to pi. So kindly refers to the calculator. Do remember to make sure that the mode is in radian. So now do remember we have to multiply with the 2. So 2 bracket where we have negative pi if we substitute the cos pi and we will have negative 1. Then for sine pi, we will obtain 0. So here we have the bracket minus. So if we substitute 0, for sure we will have 0. So finally, we will have our answer 2 pi unit square for the area. Now focus on the second part, find the volume. So as we all know, the formula for volume, where we have V is equals to pi integrate with the situation where we have sine with the angle square root of x square the function with respect to x, because it's rotated about the x-axis. So with the limit where we have 0 until pi squared. So here we have the formula for volume. Next, what we have to do is to modify the situation. So let the t is equals to square root of x. And we may write the situation like t squared is equals to x. So if we differentiate the situation, so we will have 2t dt equals to dx. Next, what we have to do is to substitute the situation. So v is equals to pi integrate where we have sine squared. So for the square root of x, we can let it as a t. And then dx will be substitute with 2t dt. So here we have the situation. So kindly rewrite the situation. So v is equals to pi So v is equals to 2 pi integrate where we have t sine squared t with respect to t. So kindly refers to the double angle. So in here we have the double angle where we have cos 2t is equals to 1 minus 2 sine squared t. Kindly rearrange the situation. So where we will have 2 sine squared t is equals to 1 minus cos 2t. Rewrite the situation. Express sine squared t is equals to 1 minus cos 2t over 2. Then substitute the situation. So v is equals to 2 pi integrate where we have t. Substitute the sine squared t. So we will have 1 minus cos 2t over 2 with respect to t. Next, simplify the situation. So where v is equals to pi integrate where we have to expand the situation. So t minus t cos 2t with respect to t. So now focus on the first part where we have to integrate the t. So if we integrate the t, so we will have t squared over 2 minus with, so for the second part, by using the Bipart method, so we have to integrate the situation. Let the u is equals to t and the dv is equals to cos 2t dt. du dt. If we integrate the v, and we will have v is equals to sine 2t over 2. Kindly substitute the situation. So v is equals to pi multiply with the t squared over 2 minus, we have a bracket, ut. So t sine 2t over 2 minus with 1 over 2 integrate sine 2t dt. Next, v is equals to pi bracket where we have t squared over 2 minus with t sine 2t over 2 a negative cos 2t over 4. So now what we have to do is to substitute the limits. So previously I have mentioned that, so in here we have 0 and pi squared. That is the value for x. So for this case, what we have to do is to find the value of t. So in order to change the value of x to t, so where we have to do is to substitute into this part. So if we substitute 0, we will obtain 0. If we substitute pi squared, and we will have pi. So now what we have to do is to substitute the value pi. So do remember, by using the calculator, make sure the mode is in radian. So v is equals to pi. So if we substitute pi, so we will have pi squared over 2 minus 0 minus 1 over 4. So minus with, if we substitute 0, so obviously we will have 0 minus another 0. Cos 0, we will have a negative 1. So if we substitute 0 for cos 2t, and we will have a negative 1 over 4. So finally, so kindly refers to this part. So very obvious, we will have 0. Then focus on this part, pi multiply with the pi squared. So the volume is equals to pi cube over 2 unit cube. So that is the answer for volume. So here we are, and thanks for watching.